Hey everyone, welcome to another edition of Ask an Astronomer. I'm Michael here at the MacMillan Space Centre, located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh, joined by our astronomer Rachel, and it is International Day of Women in Science. Rachel, you are a woman in science, and of course, science and astronomy have not always been a place for women. Of course, now it is. Did you have any mentors growing up as you were going to school and now as is your role as an astronomer?
I do. So my favorite professor at UBC, her name is Kristen Schleich, and I love her because she's exactly what I want to be. She is super passionate about her research and teaches general relativity and electromagnetism, and I always just thought that she was so cool.
Yeah, and there's so many men astronomers that we can look to as mentors, and I think today is like a really good day to recognize some of the women, and of course you are a mentor, maybe to all of the girls that could be watching this today. So hello to everyone that may be watching. Let us know where you're watching from. We're going to be getting into tons of topics over the next half hour. Put your questions into the chat, and if you're out there on Telesoptic, maybe one day come on in to YouTube so you can join in the conversation. So, Rachel, all this week, we have been a buzz about two new orbiters that have arrived on Mars, and that's going to be our main focus for this week and also for next week as well, because we'll talk about what's happening next week. Let's focus on what happened this week at Mars.
Sure. Here we go. So you should see a slide that says missions to Mars, what to expect, and what is going on right now. So I thought I'd start off with some statistics as to how difficult it is to land on Mars, and that is only about 40% of missions ever sent to Mars by any space agency have been successful. And so if we look at 40%, that's 1% away from a failing grade from an F. So it is quite difficult to land on Mars. But going to Mars will help us learn a lot, like stuff about our past, our present, our future, and maybe even the origins of life here on Earth. Now, the key to understanding the potential for life on Mars, whether it be in the past or the future, can be grouped into four science goals for Mars exploration. And that is to determine whether or not life ever arose on Mars, to study the climate and geology of Mars, and eventually to prepare for human exploration for the first Martian on Mars' surface. And so we have a few missions to Mars this month, and they are all investigating one or a few of these science objectives. And so the first one I want to talk about is the UAE Hope orbiter that arrived February 9th. And their mission goal is to provide the first complete picture of the Martian atmosphere, or what we would call atmospheric dynamics. Now, the probe will be the first to be able to study the weather cycles and variation over different geographic areas on Mars over different time spans. And the team hopes that the probe will be what they call the first true weather satellite there at Mars. And so, specifically, their science objectives are to study the weather system of Mars, monitoring for the first time weather changes throughout the day, across the planet, and during all seasons. And HOPE will also study the distribution of hydrogen and oxygen in the upper portions of Mars' atmosphere, or what we would call the exosphere. And lastly, it'll focus on better understanding the link between weather changes in the lower atmosphere with the loss of hydrogen and oxygen from the upper layers of the atmosphere as these two gases are leaking into space. So this will allow us to study the link between weather change and losing things to space, and a process that may have been responsible for Mars's transition over billions and billions of years from a thick atmosphere capable of supporting liquid water on the surface to the cold, thin atmosphere and dusty Mars that we see today.
Nice.
And so it's got three scientific instruments on board. It's got an infrared spectrometer, which will study the energy balance in the current Martian climate. We also have an exploration imager, which will take high resolution pictures of Mars. And finally, we have an ultraviolet spectrometer, which will look at the structure and variations in oxygen and hydrogen in the exosphere. And here we go. So this is when the HOPE probe was on its way to Mars, and you can see this is a picture taken by HOPE probe of Mars as it's heading towards it. And I think it's very cool to see a tiny dot being another planet in our solar system. A pale red dot, I suppose. So the agency has also stated that it has strategic objectives beyond the scientific ones, and these are centered around human knowledge and the space agency's capabilities and global collaboration. So here are some of the things that the mission will help beyond data and results. So it'll help improve quality of life, building a sustainable knowledge-based economy to inspire future generations to explore space and to demonstrate leadership in space research. So that gives us an overview of UAE's mission, and now we have the Tianwen-1 mission from the Chinese National Space Agency. And so this is China's first Mars mission, and it's very ambitious. So no nation has ever attempted to send an orbiter and a rover together to Mars on the first try. Now, getting from space to the Martian surface is a unique challenge that China will be facing for the first time. And the lander carrying the rover will use a parachute, retro rockets, and an airbag to land safely on the surface. And once on Mars, the Tianwen-1 landing platform will extend a ramp outwards, allowing the rover to roll gently onto the surface, similar to the way that China's Chang'e moon rovers were deployed on the moon. Now the rover will have cameras, instruments for studying Mars's climate and geology, and even an instrument to zap rocks and record the resulting chemical signatures, just like NASA's Curiosity and Perseverance rovers have as well. And the rover has a radar, which works by shooting radio waves into the surface of Mars and measuring the reflection times coming back. And that tells scientists a little bit about the 3D structure of what lies beneath the surface of Mars without having to drill all the way down. Now, the main task of the orbiter is to give a global and extensive comprehensive survey of the entire planet, and then to send the rover to surface locations of scientific interest and conduct detailed investigations, a lot of research with high accuracy and resolution. So I'm very excited to see the images coming from the HOPE or Tianwen-1's orbiter and also its rover, actually, for the interior structure of Mars. Now, specifically for this mission, the scientific objectives are to map the geological structure of Mars, to investigate the surface soil characteristics and distribution of water ice, to analyze the material of the surface, to measure the ionosphere and characteristics of the Martian climate and environment, also at the surface, and to look at the physical fields of Mars, which would be something like the gravitational or electromagnetic fields and the internal structure of Mars. So they're really going for a comprehensive picture of Mars here on their first try. And so I love how uniquely ambitious that is. And so these are two missions that are currently at Mars, but we also have the Perseverance mission or rover arriving next week on Thursday, February 18th, which I'm very excited for. So I thought I'd talk a little bit about what to expect and what Perseverance will be doing.
Absolutely.
So Perseverance is NASA's 5th rover to attempt a landing on Mars, and it'll touch down at around 1 p.m. PST. And during landing, the rover will pass through the thin Martian atmosphere, equipped with a heat shield, and it'll pass through at around 20,000 kilometers per hour. So of course they have to slow it down before they reach the surface, and so they have a parachute and thrusters that'll give it a powered descent, bringing it down to just 1 meter per second as it approaches the surface. And then we have a large sky crane that'll come and lower the rover onto its 6 wheels, just like it did for Curiosity. And so it'll land at the Jezero crater, just north of the Martian equator. Now, the reason why they want to land at the Jezero crater is because it once contained a lake. And because of this, we think that this is one of the most likely places we could find evidence of past microbial life. And so Perseverance is looking to answer the question, was there ever ancient life on Mars? And to help us answer this question, the rover will collect and store rock and dust samples for future return to Earth for scientists to take a more detailed look, because there are some instruments that we can't bring into space because they're too heavy or need more energy here on Earth. And so this is a map of the landing sites of Mars for NASA's Perseverance rover. You can see over here, and it's in relation to previous successful Mars missions. Now, besides the rover, we also have the Mars Helicopter Scout, or now it's called Ingenuity. And this mission is very experimental because it's a technology demonstration and it isn't at all related to the rover's scientific mission. So here are some things to know about Ingenuity. The first test of a power flight on another planet, this helicopter will attempt 5 test flights within a 30-day Martian period or a 31-day Earth window. Now, it is light enough to be carried as a passenger tucked underneath the rover, but it's also strong enough to survive the harsh Martian environment after arrival, and it weighs less than 2 kilograms. But even though it's so light, it's also very powerful and able to lift off in a thin atmosphere, and the atmosphere of Mars being less than 1% the density of the atmosphere here on Earth. And Ingenuity is quite smart because it can fly on its own without human control. We send instructions to Ingenuity from Earth in advance, but it takes off and lands and flies on its own. Now, this is no small feat. The Wright brothers showed that power flight in Earth's atmosphere was possible with the Wright Flyer in 1903, and so NASA is trying to do something similar with Ingenuity on Mars. And the goal is to have the helicopter fly for 90 seconds to distances of almost 300 meters, which we can compare to the Wright brothers airplane, which lasted for 12 seconds for a total distance of 40 meters. So not only are they doing it on a different planet, they're also doing it for much longer and much further as well. And so if all goes well, here are some things that we're expecting from Ingenuity. So it has to survive the landing on Mars, which hopefully it will. Once it lands, it has to detach and unfold itself from the belly of the rover correctly. And because Mars is so cold, it must keep warm autonomously. So it uses internal heaters and solar power to charge its batteries. And we also want to make sure the helicopter can talk to both the rover, but also Earth. And then it'll move into its tech demonstration phase, hopefully lifting off and flying autonomously and landing successfully, all for the first time on a totally different planet. And so, of course, this is an artist rendition of what it might look like when Ingenuity gets there. Here is the rover taking pictures of Ingenuity as it goes and scouts ahead the terrain before rovers go there, because then it gives us a better idea of the kind of hazards that a rover might run into. Now, the 7 minutes of terror, which is the 7 minutes that everyone is waiting for next Thursday, and that is the entry, descent, and landing, or EDL. And it's the shortest and most intense phase of the mission. It begins from the top of the atmosphere and ends 7 minutes later on the surface of Mars. And to land in that short amount of time while hitting a narrow target on the surface, that means that the spacecraft will have to slam on the brakes in a very precise but challenging way. And so during the landing, it takes more than 11 minutes to get a radio signal back from Mars. So by the time the mission team hears that the spacecraft has entered the atmosphere and when we see it, in reality, the rover is probably already on the ground. So Perseverance is designed to complete the entire EDL process all by itself. But the most exciting thing about Perseverance is I mentioned that it's going to stow and collect rock and soil samples from Mars. And this is part of a series of missions called the Mars Sample Return missions. And this is by NASA and the European Space Agency and some other agencies to return Mars samples in the early 2030s. And so this is an artist rendition of what it might look like when we're blasting tubes of rocks and soil samples off the Martian surface towards orbit, where they'll be collected by another spacecraft for return to Earth. So Perseverance will stay there, but hopefully we can shoot off those samples back to Earth. Now, just like we've returned samples from the moon, 2 asteroids, and a bit of a comet tail, samples from Mars will give us a better picture of the Martian environment and its history, and hopefully let us learn a little bit about our own history.
Okay, thanks, Rachel. So we've got lots to get to with Mars. We've got lots of questions coming in all around Mars, lots of good chatter coming in. There's a theme that I see here from the Hope orbiter that's studying the Martian atmosphere to Ingenuity that is attempting to fly in a very low dense atmosphere. So from the very top of the atmosphere where Hope is scanning to the surface, we're thinking about the air on Mars, and some questions come around, could we breathe this air? And if not, how could humans, breathe? We need oxygen to breathe. There's clearly not environment there for humans to breathe. So, what are some of the things that you think humans might do to survive on the surface?
So currently, if we were to send a person to Mars, not only is the atmosphere ultra thin, but the atmosphere is also made of different ingredients than Earth and in different proportions. So Earth has a lot of oxygen in our atmosphere, nitrogen, and Mars has a almost completely carbon dioxide filled atmosphere. So that, of course, is not great for us to breathe. We need the opposite of that. We need oxygen. So we'll have to do a few things before we get there. And there's a couple of ideas. I know that there are some out there ideas, which I'm going to say Elon Musk has the idea to drop bombs on the surface to make it a little bit more warmer. But there's also the idea of making domes on the surface of Mars. There was a challenge from NASA to figure out the best way to 3D print a home or a dome on Mars. And I think that that's a really cool idea. But of course, you'll need to wear spacesuits anytime you are outside.
Yeah. I was just listening to the Planetary Society podcast. Bill Nye is the CEO, and the host of the podcast, had a bet with Bill Nye about whether we will terraform Mars. It's something that would probably take thousands of years. It would take a very long time to change the atmosphere of Mars, and that's sort of what Elon Musk is saying, is sort of like melt that ice and sort of like create a new sort of like water cycle there. Bill Nye says it'll never happen. He thinks it's impractical, nearly impossible. But lots of science fiction writers have delved into it. I'm actually just finishing up Kim Stanley Robinson's Red Mars. I don't know if you've read that, Rachel. Lots of variety of ideas of what humans could do there. But we're having those conversations right now, and a lot of these missions right now are we still need to know more about Mars, what's underneath the soil, what's in the atmosphere. That's a big chunk of what we're doing here with these robots. Let's keep going with some of these questions. We're going to have lots of questions. I know that we've got a couple classes. We got Mr. Bamford's grade 4 class. How's it going, everyone? And also Division A3 from Glenbrook Middle School. So if you got some questions, pop them in here. We've got another 11 minutes to go. Let's see here. Rachel, this one comes from Nick. Do you know if we will ever send a rover to Valles Marineris, or have something observe Phobos or Deimos in detail?
So we do have a mission going to one of the 2 Martian moons. So we do have that mission in the works. I don't remember the name of the mission, but it is focused, I believe, on Phobos and looking to map all the characteristics and surface features of that moon. In terms of sending a rover to the Mariner Valley, I'm not sure if they will. And the reason I say that is because the Mariner Valley is basically the supersized version of the Grand Canyon here. And so the only reason I could think that they would want to send something there is to look at the bottom of the canyon, but it would be really difficult to land something there, let alone getting something to drive its way off a cliff and down to the bottom of the valley.
Right. Yeah. So I can see like there might be some benefit to getting down there. So what you're saying is just like it's likely impractical at this point until maybe we can get a helicopter to maybe fly over the valley. Maybe that'll be just as good. And some more questions coming in. Aiden and Lucas ask, what's the percentage that we will be able to live on Mars? What do you think, Rachel? Do you think humans are going to be able to live on Mars?
Yes. So 100% yes, I think that humans will live on Mars. It's just a matter of time. I don't think that Elon is his estimate is very optimistic. I think he said 2026 he wants people on Mars, 2030s.
Hmm.
I think it'll take a little bit longer than that because you really want to make sure that we iron out all the kinks before we send living, breathing humans to a Martian atmosphere.
And on that note about Deimos and Phobos, I've heard lots of people that think those moons might be more practical to set up outposts because it's a lot easier to land and take off on those moons as opposed to landing on Mars because of the dense atmosphere. Taking off from the surface of Mars is proving difficult. We haven't done it yet, but that animation that you showed, with the return, you need almost to build, a whole rocket tower before we even get there. Um, let's see what other questions that we got coming in. What about power on the moon? So obviously, once these rovers are down there, we see the rovers that have those solar panels. But the Ingenuity helicopter, you say they'll have to survive sort of like through the night. So is there does it have a lifespan? Is it not expected to last as long as the rover?
So, Ingenuity does have solar panels to charge its batteries, but with solar panels, which Curiosity has, I think Spirit and Opportunity have as well, and Perseverance will have, the challenge with that on Mars is dust storms. Because dust storms
Mm.
are they can be a global event on Mars. They can cover the entirety of Mars, and they did actually have a problem with that. NASA did, with the two rovers, Spirit and Opportunity, where they had a bunch of dust covering the solar panels, and because that happened, they weren't able to get any energy or power. So they were actually kind of worried that all this dust will halt their missions. But eventually, they ended up clearing up the solar panels and getting it that way. But the idea is that Ingenuity hopefully will last as long as it possibly can, whether that's dependent on it being able to survive the intense temperatures or not being able to store enough power for its batteries.
Right. And just like any other mission, I imagine, like if it does survive, and it's still working, they'll probably maybe add on to its missions. Right now, it's got that, primary mission survive and then see if it can fly as that test. But, I imagine if everything goes like super smoothly, they'll be like, hey, let's see if we can find something else for Ingenuity to do. And of course, speaking of dust storms, if anyone has ever seen the movie The Martian, I highly recommend it. It's great for anyone that's in middle school. Really scientific. The Andy Weir, who wrote it, put a lot of great science in there. Although the one main incident at the beginning, when you're talking about a dust storm, Rachel, you're not quite talking about a hurricane, right? Like we say on the movie.
No, but that scene was exactly what I was envisioning as well when I heard that Spirit and Opportunity experienced that. But it's kind of crazy to think that this kind of storm can cover the entire planet. So Mars is a little bit smaller than Earth, but if you imagine a global storm happening all over Earth, it's a little bit hard to imagine. So it's both cool and terrifying that it's happening on Mars.
Right, absolutely. Mr. Banford's class would like to ask you, Rachel, would you like to go to Mars?
Yes. Yes, on the condition that we've figured out everything already. Um, but yeah, I don't think I would be the first person to Mars, but I would definitely go at some point.
Yeah, no, you know what? I would probably go as well. Although you're probably looking at, like at least a 2-year mission. So, it's a really long vacation, really. It's kind of like us in the pandemic right now. We're on a really long vacation. We could do it. We could go to Mars and back as long as we have some good movies to watch on the way.
Quarantine on another planet.
That's pretty much what it would be like, right? Wouldn't be a whole lot of people to talk to. Let's talk about a few other things because we've only got a few minutes left. Yesterday was Space Debris Day. Rachel, you want to talk a little bit about what space debris is? People can go and watch. It's on YouTube right now. Full hour discussion. Rachel, what is Space Debris Day and what is space debris?
Sure. So space debris is a very important thing because things like the ISS run into space debris all the time. So it's a bunch of, I'm going to call space junk orbiting the Earth at various different altitudes. And the most important impact for astronomy we talked about yesterday was these satellite constellations or these mega constellations. And the problem with that was that we were worried that these satellite trails or when they reflect sunlight will be too bright for our astronomical imaging, especially for when we want to take wide field surveys of large parts of the sky. We'll always have these satellites, these lights drowning out all of the light we want to get from deep space objects. And there's also the problem of the Kessler effect, which is when you have almost an exponential collision going on. So a piece of space debris hits another one that generates more debris and more debris as they keep colliding. And so we have a lot to think about for our future in terms of policy, as Aaron and Brian were talking about yesterday, as to how we're going to move forward with Earth's airspace.
Absolutely, and we had a fascinating discussion. So I highly recommend if that sounds interesting, learning about this very complex and new-ish for a lot of people. That's going to certainly become a bigger issue as private companies and more countries, as we've seen today, Rachel. We've got the UAE and China going to Mars, but that's Mars. When we talk about our atmosphere, we're talking about the satellites. There are tons and tons of countries and private companies that are sending these satellites up, and so we need to create some guidelines, I think, before some disasters really start to happen. We've got a few minutes here. Let's go to a bonus question here, Rachel. Next month we're going to be celebrating Einstein's birthday on March 14th. So a question, comes around black holes, which Einstein first predicted. Do scientists know if black holes could disappear?
So this would be where Stephen Hawking comes in. Sorry, Einstein, but this is Hawking. And Stephen Hawking's big thing was Hawking evaporation and Hawking radiation. And that was the idea that a black hole could shrink in size and lose stuff or matter or energy through this radiation. So it's radiating away almost like a star would radiate away energy. This instead is allowing the black hole to shrink further and further. But because it happens so slowly, we've never been able to see any sort of or record any sort of data on that kind of event. And so we're still waiting, but it is definitely possible, according to Stephen Hawking. So I'll take it from that.
We just need time, right? But of course, we're bound by these earthly bodies. In the future, they keep looking. Perhaps we'll see it one day, right? So just the last few minutes here, Rachel, let's preview what we've got coming up. On Sunday is Valentine's Day. We're going to be doing a really fun special day where we're going to be doing stellar shoutouts. Of course, we're mostly locked in to our homes. Perhaps we're missing someone that we haven't seen. If you'd like to send a message that we could dedicate into the stars, Rachel's going to find some stars and I'll read out your messages. We're doing a special event on Sunday for Valentine's Day. Check our website, spacecenter.ca, for some of that info. And then on Thursday, like Rachel said, Perseverance is going to be landing on Mars, or hopefully landing on Mars, live streamed around 11. But in the evening, we're bringing in Dr. Tanya Harrison, who's on the team that helped choose Jezero Crater as a landing site. So we're going to be going a little bit deeper dive for a full hour in Zoom. So go onto our website and register for that. It's going to be a really fun event. We're going to do some trivia. We're going to give away some prizes and really get to dig deep, metaphorically, into Mars and really like how we choose, why we choose to go to certain places on Mars. It's going to be really fun. All right, everyone. Thank you so much for joining us for another edition of Ask an Astronomer. We'll be back here on YouTube in 2 weeks. Until then, take care.